Hello friends, today we will start the next chapter called the matrices and determinant. So in this lecture we will study the definition, the types of matrices and the operations on the matrices. So we will start with the topic. So firstly we will see the definition of the matrix. So we will write the definition. So matrix is basically an arrangement of numbers in rows and columns in a rectangular array. So that thing will be called the matrix. Now things to understand here. There will be arrangement of numbers in rows and columns, okay, in a rectangular array. That will be called the matrix. So in general, suppose I will consider a matrix. Suppose that is a matrix A. It will be denoted by matrix Aij, okay, where this I will take values from 1 to 3 up to n, and j will take values from 1 to 3 up to n. If I will elaborate this matrix A, then see what will happen, what I will get. I will get this thing, okay. If I will vary this I and this j, I will get vary from 1 to m and j will get vary from 1 to n. Then see what will happen. I will get first set of numbers, that will be A11, A12, A13 and so on, A1n, okay. Second set will be A21, A22, A23 and so on, A2n, so on, AM1, AM2, AM3, so on, AMN, okay. So this will be called the matrix A, okay. Now if you observe the horizontal arrangement will be called the rows of the matrix. Horizontal arrangement of numbers will be called the rows of the matrix, and the vertical arrangement of numbers will be called columns of the matrix, okay. Now again, if you observe here, this matrix contains m rows. Suppose this is your first row, okay. I will say this as R1, first row. This will be second row, R2 and so on. This will be mth row, okay. So it contains m rows. So I will write it here, m rows. And if you will observe again, it contains n columns, okay. So this will be first column C1, this will be second column C2, third column C3 and so on. This will be the nth column Cn. I will write it here. This thing is called order of the matrix. This is what? Order of matrix, okay. Now in this particular case, the order of this matrix is m cross n. It can be read as m by n also. In this, m will be number of rows. M is number of rows and n is number of columns, okay. So depending on how many rows and how many columns are present in the matrix, so that we will define its order, okay. For example, if I will take the matrix A, suppose the matrix is like this 1 2 3 4. So if you will observe, it contains two rows. This is first row, this is second row, okay, and two columns. So this will be first column and this will be second column. So order of this matrix will be 2 by 2. It contains two rows and two columns. Second example, if I will take the matrix like this 1, 2 and 3, again if you will observe here, it contains 3 rows R1, R2 and R3 and only one column C1. Okay, so its order will be 3 by 1. Okay, so this is how we define the order of the matrix. Okay, now next thing is determinant of the matrix. Determinant of matrix. Okay, now what is determinant? So determinant of only square matrix is defined. Square matrix is defined. Now thing is how to get the determinant. Okay, suppose I have the matrix A. Okay, so matrix A is suppose A, B, C and D, then the determinant of the matrix A will be denoted as determinant of A, or it can be denoted as determinant of A, and it is given by determinant of A will be equal to, now what you will do, you just need to take the cross multiplication A into D and subtract C into B. Okay, so determinant of this will be A into D subtract C into B. Okay, so this will be a number that will be called the determinant of the matrix A. Is it clear? Now suppose I have the example, suppose matrix A is 1, 2, 3, 4. Okay, then the determinant of A will be 1 into 4 minus 2 into 3, which is 1 into 4, 4 minus 6, which is equal to minus 2. So this value denote the determinant of this matrix A. Okay, suppose I have the matrix of order 3, a square matrix of order 3. Now what means square matrix? Square matrix basically contains number of rows equal to number of columns. Suppose I have this matrix, square matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, its order will be 3 by 3, and I need to find the determinant of matrix A. It can be also written as a determinant of A, mod of A, and it will be given by, now to find the determinant of such a matrix, firstly you need to identify the elements present in the first row. This is your first row. Okay, so what we will do, we will take this first element A11, okay, and in bracket see what will be present here in bracket. Now the number which is present here, which is A11, you need to hide this row and hide this column. Okay, so what will remain? Only this sub matrix will remain. Okay, you need to find the determinant of this sub matrix. Okay, and its determinant will be A22. Take this cross multiplication. Okay, so this will be A22, A31. Okay, so see this, what will happen? A22, A33 minus A23, A32. Okay, then minus second element A12. Okay, and in bracket, now again hide the column where that element is present. Now we will hide this column and hide this row where the element is present. Okay, so what remains? These numbers remains. Okay, that will be called the sub matrix of the matrix A, and we will find its determinant. Okay, so that will be A21 A33 minus A23 A31. Then the next entry will be plus, now third element is what? A13. Okay, in bracket. Now hide the column where that element is present. Now this element is present in the first row and in the third column. Okay, so we will hide those elements, and what remains? This submatrix remains. Okay, so we will write it as A21 A32 minus A31 A22. Okay, this is how we find the determinant of any 3 by 3 matrix. Okay, so that is called the determinant of the matrix A. For example, suppose I have the matrix 1 0 1 2 1 3 1 1 1. Okay, and I need to find the determinant of this matrix A. So the determinant of this matrix A will be denoted by mod of A, and it will be, now where is the first element? This is the first element, so I will write it here 1 into, what will be next term? Now hide the row and column where this element is present. So this element is present in this column and in this row, so we will hide it. So this will be your remaining submatrix. So find its determinant. So that determinant will be 1 into 1 minus 1 into 3, then minus, okay, this minus sign, minus second element is what? 2. So we will write this 2 here. Okay, then again hide where that 2 is present, hide the column and row where that 2 is present. Okay, so we'll hide this row and second column. Okay, so what remains? 0 1 1 1. Okay, so find out its determinant. This will be 0 into 1 minus 1 into 1. Okay, plus third element is what? Third element is this one. We will write this one here. Okay, again hide this row and this column. Okay, so what remains? Only this much submatrix is remains. So find its determinant. This will be 0 into 3 minus 1 into 1. Okay, so this will be 1 into 1 is 1 minus 3 minus 2 into 0 minus 1 plus 1 into 0 minus 1. So this will be minus 2 and this will be minus 1. So that is what? Minus 5. So this minus 5 will be determinant value of the matrix A. Okay, so this is how we find the determinant of any matrix. It may be of order 2 by 2 or of order 3 by 3. Now we will see the types of matrices. Okay, so in that the first type is called row matrix. Okay, so the matrix will be called the row matrix if it contains only one row. Okay, the matrix which contains only one row is called row matrix. For example, if I will take the matrix A is equal to A11, A12, A13, so on, A1n. Okay, now if you will observe, this matrix contains only one row. Okay, this is the only one row, so its order will be 1 and it contains n columns. Okay, how many columns are there? N column. This is first column, this is second column, this is third column, and so on up to nth column. It contains n column, so order of this matrix will be 1 by n. As it contains only one row, that is why it is a row matrix. Okay, second example, suppose I will take this as 1, 2 and 3. Now again it contains only one row but 3 column, so it will be the row matrix. Okay, now next type of matrix is the column matrix. Okay, now obviously the matrix which contains only one column is called column matrix. Okay, for example, suppose I will take the matrix A is suppose A11, A21, so on, A M1. Okay, so this is a matrix whose order is M cross 1. Okay, because it contains M rows. Okay, so this is the first row, second row, okay, up to mth row. So it contains M rows and only one column, so that is why it is a column matrix. Okay, for example, matrix B, A, B, C. Okay, so again ABC are the values, are the numbers. Those may be real numbers or the complex numbers. Okay, so again it contains 3 rows and only one column, so it is a column matrix. Okay, clear? Now the third type of matrix is called zero matrix. Okay, so any matrix will be called zero matrix if all the entries in that matrix are equal to 0. Okay, so what is the definition? All the entries are equal to 0. That will be called the zero matrix. Okay, for example, I will take this matrix A 0, 0, 0, 0, okay, whose order is 2 by 2, contains 2 rows and 2 columns. All the entries are equal to 0. That is why it is a zero matrix. Second matrix, suppose matrix B is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. Its order is 3 by 3. So all the entries are equal to 0. Again it is a zero matrix. Okay. Fourth type of matrix is a diagonal matrix. Fourth type is the diagonal matrix, or before that you must know what means square matrix. Okay, so the matrix is said to be square matrix if the number of rows in the matrix should be equal to number of columns. Okay, number of rows should be equal to number of columns, or number of columns should be equal to number of rows. For example, if we will see the matrix, suppose matrix A is like this: 1, 2, 3, 4. Okay, so the order of this matrix is 2 by 2. So rows are 2 and columns are also 2. So that is why it is a square matrix. Okay, if I will take one more example, suppose this is a 1, 2, 3. Okay, so it contains 3 rows but only one column. Okay, so number of rows are not equal to number of column, so this is not square matrix. Clear? Now next thing is type 5 is a diagonal matrix. Okay, so to identify whether the given matrix is a diagonal matrix or not, you must understand firstly that it should be square matrix first. Square matrix. Okay, and second thing, every non-diagonal element are 0. Okay, every non-diagonal elements is 0. Okay, so this is the requirement for the matrix to be diagonal matrix. Okay, first is what? It should be square matrix. Square matrix means the number of rows should be equal to number of columns, and second thing, every non-diagonal element should be equal to 0. Okay, for example, if I will take the matrix A, okay, 1 2 3. Now question is, what is the diagonal of this matrix? So diagonal of this matrix will contains the element 1 and 4. Okay, this will be the diagonal, and the diagonal will contain the element 1 and 4. Okay, so to get the diagonal matrix, suppose I will consider the second example, matrix B, A B 1 3. Okay, now is it diagonal matrix? The answer is no. Okay, because why? The diagonal of this matrix is what? A in 3, A and 3, and the non-diagonal element. What are the non-diagonal element? This B and this 1. It should be 0. Okay, which are non-zero here. So this is not diagonal matrix. Okay, third example, suppose I will take this as 1 0 0 2. Okay, now what is the diagonal? Diagonal is 1 and 2, and non-diagonal element are equal to 0. So this is a diagonal matrix. Okay, we can see one more example for this. Suppose this is a matrix D. Okay, this is a 1 0 0 0 1 0 0 0 2. Okay, now what is the diagonal of this matrix? Diagonal is 1 1 2, and all the non-diagonal entries, these are the non-diagonal entries which are equal to 0. So it is a diagonal matrix. Clear? Now next thing is, what means scalar matrix? Scalar matrix. Okay, now it also has two requirements. The first requirement is that it should be diagonal matrix. Firstly, it should be diagonal matrix. Now we know what means diagonal matrix. And second thing, all the diagonal elements should be equal. All diagonal elements are equal. Okay, now we'll take the example. Suppose this is the matrix A. Suppose matrix is like this: 1 0 0 0 1 0 0 0 1. Okay, now first question is whether it is a diagonal matrix. So answer is yes, it is a diagonal matrix, because all the non-diagonal elements are 0. If you observe here, all the non-diagonal element are 0, so it is a diagonal matrix. Now next thing is second condition, all the diagonal elements are equal. Now what is diagonal? Diagonal contains what? Diagonal contains the element 1 1 1, and all the elements are equal, so that is why it is a scalar matrix. Okay, second example, suppose matrix B, okay, 2 0 0 2. Okay, now is it the scalar matrix? Then the answer is yes, because firstly it is a diagonal matrix, and second thing, all the diagonal elements are equal. What is the diagonal here? Diagonal contains the element 2 and 2 are equal, so that is why it is a scalar matrix. Okay, now next thing is, what means unit matrix? Okay, what means unit matrix? 7 number, unit matrix. Okay, now firstly it should be diagonal matrix, or it should be diagonal matrix. Obviously it is a diagonal matrix. Okay, and all diagonal elements are equal to 1. equal to 1, then only it will be the unit matrix. The unit matrix can also be known as identity matrix. Identity matrix. Okay. The standard notation for identity matrix is capital I. Okay. So if I will consider the matrix, suppose I2. Okay, I2 will contain the element like this 1 0 0 1. Okay, now thing is whether it is satisfying the conditions or not. Okay, so clearly it is a diagonal matrix. Okay, and all the diagonal elements are equal to 1. So it has diagonal 1 1. So it is a identity matrix. We can consider the matrix of order 3. Okay, this will be 1 0 0 0 1 0 0 0 1. Okay, so this is a matrix of order 3 by 3. That is why I have written here as 3. Okay, so it is a diagonal matrix and all the entries along the diagonal are equal to 1. So that is why it is a unit or identity matrix. Now next type of matrix is a upper triangular matrix. Upper triangular matrix. Okay, now which matrix is said to be upper triangular matrix? Okay, so all the entries below diagonal are 0. Okay, for example, if I will consider this matrix 1 2 1 0 0 2 0 or 3 0. Okay, I will rewrite 3 0 4 5 and 6. Okay, now the diagonal of this matrix contains the element like 1 3 and 6 and all the entries below the diagonal. Okay, see the definition, below the diagonal. Okay, so all the entries below the diagonal are 0. So that is why it is called upper triangular matrix. That is why it is a upper triangular matrix. Okay, second example we can see. Okay, suppose this is a 1 0 3 4. Okay, so what is the diagonal in this case? Diagonal is 1 4 and all the entries below diagonal are 0. So this is again what? Upper triangular matrix. Okay, now 9 number is lower triangular matrix. Lower triangular matrix. Okay, now but which matrix will be lower triangular? If all the entries above diagonal are 0. Okay, for example, suppose I will take the matrix like this 1 2 3 0 4 5 0 0 6. If you will observe here again, the diagonal contains the element 1 4 6 and all the entries above the diagonal are 0. So that is why it is a lower triangular matrix. Okay, it should be clear from this. The matrix B, suppose I will take this as 1 2 0 3. Okay, again the diagonal in this case is 1 and 3 and all the entries above the diagonal is 0. So this will be lower triangular matrix. Okay, now the next type of matrix is called triangular matrix. Triangular matrix. Okay, so if the matrix is upper triangular and lower triangular at the same time, then it will be triangular matrix. For example, if I will take it like this: 1 0 0 0 2 0 0 0 3. Okay, now clearly the diagonal of this matrix is 1 2 3. So this matrix is a upper triangular matrix because all the entries below the diagonal are 0, and also it is a lower triangular matrix because all the entries above diagonal are 0. So it is upper triangular as well as lower triangular. That is why it is a triangular matrix. The triangular matrix is also called the diagonal matrix. The triangular matrix is also the diagonal matrix. Okay. Now next thing is the symmetric matrix. Okay. What means symmetric matrix? Symmetric matrix. Which matrix will be called the symmetric matrix? Now here you need to understand the concept. Okay. For this, suppose I will take one matrix like this. Matrix A is suppose A11, A12, A13, A21, A22, A23, then A31, A32, A33. Okay, this will be the matrix of order 3 by 3 as it contains 3 rows and 3 columns. Okay, now if you observe this element A12, okay, A12. Now if you observe the suffix here is 12. Now this suffix 12 denotes the position of that element inside the matrix. Okay, this 1 denote the position of the element at the row. Okay, means what? This element is present at the first row and at the second column. Okay, if you observe this element A12 is present at the first row and at the second column. So this will be the element A12. Okay, similar way we can define in general what will be this element Aij. So this Aij is the element which is present at the ith row and at the jth column. Clear? So basically Aij denote the position of the element inside the matrix. Clearly? Now thing is, what means symmetric matrix? Okay, the matrix is said to be, it's said to be symmetric if and only if the elements will be like this: Aij should be equal to Aji. Okay, means what? If I will take the element A12, that should be equal to A21. Okay, now if you will observe in this matrix, A12 is here. Okay, and where is A21? This is A21. If both the entries are equal, okay, then this matrix will be called the symmetric matrix. Okay, not only for A12, you can see for A13 also. If this is A13, if this value will be equal to this value, then it will be symmetric matrix. Okay, again for this also A23 should be equal to A32, then it will be symmetric matrix. Okay, we will take one example. Suppose consider the matrix 1 2 3 2 4 5 3 5 and 6. Okay, now if you observe here, this is entry A12, okay, and this is entry A21, both are equal. Yes. Now if you observe again, this is entry A31 and this is entry A13, okay, are equal. Then again if you observe, this is entry A23 and this is entry A32, are equal. So that's why this matrix will be symmetric matrix. Okay, one more example. Suppose matrix A is 1 5 3 5 6 4 3 4 9. Okay, now observe the entries here. This is entry A21, this is entry A12, this is entry A21 are equal. Then this is entry A13, this is the entry A31 are equal. Then this is entry A23 and this is entry A32 are equal. So that is why it is a symmetric matrix. Okay, one more example. 1 3 3 4, there is no restriction over diagonal. Okay, now again if you observe here, this is entry A12 and this is entry A21 are equal. Okay, A12 equal to A21, so that is why it is a symmetric matrix. Okay, one more example. If I will take this as A2 3 2 5 4 3 1 6. Okay, now again observe here, this is entry A21 A12 and this is entry A21 are equal, it's fine. Then this is entry A13, this is entry A31 are equal, fine. Then if you observe here, in this case this is entry A23 but this entry A32 are not equal, one is not equal to 4. This means this is not symmetric matrix. Okay, fine. So this is how we can study the matrices and the types of matrices. In the next lecture we will study what are the singular matrices, non-singular matrices, transpose of the matrix, and how to operate over the matrix. Okay, so let's see in the next lecture. Thank you.